Alright, this is Scholar Chef doing some math. Today we're going to be looking at segments and congruence. My page is a little bit cut off here, that's why it's at the bottom. 1.2, using segments and congruence. So we'll start off with one of these big things in geometry, well, in math. It's called a postulate, or also known as an axiom. And it's a rule in math that is accepted as true without proof. A theorem is a rule in math that can be proved to be true, and a proof is a logical argument that shows that a statement is true, usually in two columns. We'll get to proofs in chapter 2, I believe. But here we go. The ruler postulate. So points on a line can be matched 1-to-1 with real numbers, and the number that corresponds to that point is the coordinate of that point. So what it's basically saying is you take out a ruler, and you know how all the 1 inch or 1 centimeter lines up with a particular mark. That's basically what it is. So we have a ruler, and like we're looking at 2 points here. Let's just call this A and B. They would have coordinates, like this is at 3 inches, or this is 6 inches. They would have particular coordinates, right? And we label those, on a ruler, we label those coordinates, and we call those coordinates, how long it is. Inches, centimeters. The distance between 2 points on is the absolute value of the difference of the coordinates of the points. So it's basically saying we take our second x coordinate. So I'm using subscript here. That means the number is below, like it's on a different level, but it's on the lower level. So, for example, if I use it on the upper level, that's the exponent. That means squared. Down here, it means, in this case, it means the second coordinate minus the first coordinate. And then we take the absolute value, and that gives us the distance between A, B. Okay. We'll do more examples later. The segment addition postulate. So this one says, so let's say here's A, B, and C. Let's call this segment AB, and let's call this segment BC. What the segment addition postulate says is that we can take 2 segments, and as long as they're on the same line, we can add them together. To make the whole piece. So I'm taking the small piece AB and the other small piece BC, and I add them together to create the whole segment. You break let's say you have 2 pieces of a candy bar, you combine them to make a full candy bar. So postulate, remember, just a rule that we accept without proof, because common sense, I could take these 2 pieces, add them together, and make a big piece. Congruent segments. So this symbol here, so it is this equal sign with a squiggly on top. So equal sign with a squiggly means congruent. and it means the two segments are equal. Same size or same length. So there's a reason why we don't use the word equals, because congruent usually means same size, same shape. It's talking about the whole object, while equal we use for like measurements, like, oh, the length of this is the same as this, and so on and so forth. So you might see this in your book. So here's A, B, here's C, D. And if I drew them right, they have the same length. And they'll have these like two tick marks. Or they'll have a single tick mark. Actually, I can use... Let me redraw that really quick. I have colors. I think your book uses red a lot, or blue. So they'll have these two tick marks mean, and that means AB, the segment, is congruent to segment CD. And then the length of AB, so when we say length, we just put AB without the segment on top. So the length of AB is equal to the length of CD. Okay. Alright. Now, some problems on your homework, you might need a ruler. Let's just, if a problem like that shows up, go ahead and skip it, because I'm not going to expect you to print it out, grab a ruler. I mean, if you already print it out, then you can do it if you want, but if you see that on your homework, just skip it, but just know how to do this. So D, so we're trying to find the length of CD. So we need to find the coordinates of D. D's at 4. So this is 10, 20, 30, 40, 47. Oh, sorry. These are in centimeters. This is 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. Okay. So this is 4.7 minus C is at 1. So this is 3.7. That means the length of CD is about 3.7 centimeters. Okay, example 2. So find the length of KL. So use the segment addition postulate. So segment addition postulate means I can take JK and add KL to make JL, or K, or yeah. So we know that 15, and let's call this piece X, is 38. So what I did was JK plus KL equals JL. So part B, solve the equation to find the length of KL. So subtract 15 both sides. Boom, boom, boom. Boom, boom, boom. X equals 23. So KL is 23. Okay, example 3. Plot 4, 5. Oh, 4, 5. This is hard to see. 1, 2, 3, 4. 1, 2, 3, 4, 5. Negative 1, 5. H is 3, 3. And J is 3, 2. 3, negative 2. Okay. So F, G, H, and J. So RFG and HJ congruent segments. Okay? So we need to find the length of FG, which is so 4 minus 1, which is 5. Or you can just count on the plane here. 1, 2, 3, 4, 5. And then HJ, so 3 minus 2, it's also 5. So yes, they are same length. That means FG is congruent to HJ. And don't forget the bars. It means they're segments. Alright, let's move on. Alright, checkpoint 1. Use the segment addition postulate to write an equation for the length of QS. So the segment QS. Alright. So QS, we're doing length. Length is QS equals QR plus RS. Okay. Solve the equation to find the length of QS. So QS equals 31 plus 30. So QS is 61. Use the segment addition postulate to write an equation for the length of PQ. So, boop. PR equals PQ plus QR. So 55 equals PQ plus 31. PQ equals 55 minus 31. So PQ equals 24. Alright, checkpoint 2. So we got -2, comma, -1. 4, comma, -1. Oh. 1, 2, 3, 4, -1. C is 3, 0. And D is 3, 5. So that's 5 there. And I believe this is 1, 2, 3, 4, 5, 6. No, because AB is 6 and CD is 5. So AB is not congruent. So you put the congruent side and then slash through it. CD. Alright, and that's that for section 1.2. Have a good day. Oh yeah, don't forget to label your points. So if you ever have to graph one of these. So A was down here. This was B. This was C. That was D. Alright, have a good day.